பார்த்ததனுடைய ஒரு small continuation. The uniform continuity இன்னொரு 4 example. That is f of x equal to x. என்னென்ன uniform continuity எப்படி செக் பண்ணணும்னு சொன்னோம். That is lipids condition satisfy பண்ணணும். That is derivative is bounded இருந்ததுன்னா that is called the uniform continuous. எல்லாம் epsilon delta definition. இல்லை ரெண்டு sequence எடுத்து அந்த ரெண்டு sequence உடைய difference is converges to 0. Then the corresponding function difference is also converges to 0. That is called the uniformly continuous. So the mostly very important is the lipids condition. That is f of x equal to x on 0 comma 1 open interval 0 comma 1 na lipids condition f of x minus f of y என்றது that is mod of x minus y வந்துரும். So the constant here k it's look like mod of f of x minus f of y less than or equal to some k into mod of x minus y. So the k here 1 and the less than or equal to பதிலா equality இருக்கு. So lipids condition satisfy பண்றதுனால this function f of x equal to x on 0 comma 1 is uniformly continuous on 0 comma 1. So what about the x square? X square பார்த்தீங்கன்னா that is the same way modulus of f of x mod f of y. So this is equal to mod of x square minus y square and this is equal to mod of x minus y mod of x plus y. So what about the mod of x plus y? Is it bounded? That is in the interval 0 comma 1. Yes, sorry, 0 comma infinity. 0 comma infinity la is it bounded? That is idea. 0 comma infinity la is bounded or the mod of x plus y. It's a lipids condition satisfy பண்ணதுனால the function is uniformly continuous. Function is uniformly continuous. So இங்க பாத்தீங்கன்னா 0 comma infinity la mod of x plus y என்றது not bounded. Mod of x plus y is not less than or equal to k for all x in 0 comma infinity. So therefore this is we can't express the another the lipids condition satisfy பண்ணாது அதனால f is not uniformly continuous on 0 comma infinity. So what about the sin x? Sin x is the derivative is cos x bounded by 1, that is f is satisfy the lipids condition with the constant 1, therefore the derivative வந்து bounded இருக்கிறதுனால the sin x என்றது is a uniformly continuous. So always in the 0 to infinity. And lipids condition mod f mod sin x sin y என்றது less than or equal to x minus y. இது 1 by 1 plus x square on 0 comma infinity பார்த்தீங்கன்னா இதனோட டெரிவேட்டிவ் கண்டுபிடிச்சினா this is the derivative. இதுக்கு மாடுலஸ் போட்டீங்கன்னா so 1 plus x square whole square இருக்கு. So 1 plus 2x square plus 1 plus x square whole square நீங்கள் எடுத்துட்டீங்கன்னா is it bounded? நாம செக் பண்ண வேண்டியது இது bounded ஆன்னு செக் பண்ணணும். இது bounded ஆன்னு செக் பண்ணா I give the name g of t, that is t greater than equal to 0. இதுக்கு மேக்ஸிமம் இருக்கான்னு செக் பண்ணணும். இந்த ஃபங்க்ஷனுக்கு மேக்ஸிமம் இருந்தால் that is bounded. So இதுக்கு மேக்ஸிமம் இருக்குமான்னு செக் பண்ணணும்னா that is the derivative equal to 0 க்கு ஈக்குவல் பண்ணி some point கண்டுபிடிச்சிட்டு that is இங்கே t equal to 1 by root 3 னு வருது and the second derivative test apply பண்ணலாம். Okay, the second derivative test apply பண்ணிட்டு this is the maximum occur ஆகுது அப்படின்னு சொல்லலாம். That is the maximum is g of 1 by root 3. Okay, so இதுக்கு maximum occur ஆகுதுன்னா the f dash of x is as the maximum, that is the modulus of this one is less than or equal to g of 1 by root 3, g of 1 by 3 அப்படின்னா இதுக்கு maximum occur ஆகுதுன்னா the f dash of x is bounded for all x belongs to 0 comma infinity. So therefore this is the uniformly continuous on 0 comma infinity. அதுவும் இல்லாமல் இந்த denominator பார்த்தீங்கன்னா x square plus 1 தான், that is the complex number. X square plus 1 equal to 0 னா that is not a real number. So x square equal to minus 1, that is equals to x equal to plus or minus I, x equal to plus or minus I. So இது complex number என்றதுனால that is in 0 comma infinity the function as uniformly continuous on 0 comma infinity. And also some result பார்த்தீங்கன்னா the function is real valued function. Suppose f is a real valued function on a comma b close to the bounded interval a comma b, the absolute value of the slope of the every secant line. Every secant line on the graph of f is less than 1 ஆகுதுன்னா that is called f is a uniformly continuous on closed and bound interval a comma b. Closed interval a comma b. The secant line அப்படின்றது என்ன அப்படின்னு பார்த்தீங்கன்னா that is the slope of every secant line. ஸ்லோப்புன்றது என்னன்னா that is called slope ஜென்ரலாக என்ன பண்ணுவோம் y2 minus y1 divided by x2 minus x1 போட்டிருப்போம். இந்த y1ன்றது y2ன்றது corresponding x2 உடைய image, x1 உடைய image is called the y1, that is f of x2 minus f of x1 divided by x2 minus x1, that is called the slope. So the slope of every secant line on the graph of f. So for all x comma y belongs to a comma b, x is not equal to y. So that is the slope of every secant line, that is f of x minus f of y less than divided by x minus y less than 1 na the just cross multiply பண்ணனா that is satisfy the Lipit's condition. Lipit's condition satisfy பண்ணுச்சுனா that is called that function is uniformly continuous. That is the idea. அதே மாதிரி f be a uniformly continuous on the real valued function on 0 comma 1. f ன்றது uniformly continuous on 0 comma 1 open interval 0 comma 1 na limit x tends to 0 plus, that means 0 plus right hand limit of the 0, right hand limit at the point 0 is exist, right hand limit of the point 0 is exist. So the function is uniformly continuous on the real valued function at 0 comma 1 ஆகுதுனா. The same way this is the f is continuous on the r. f ன்றது continues on r and the limit at the point infinity is 0 and limit at minus infinity is also 0. Infinityலையும் 0 minus infinity 0 வருது. function is continuous on r இருந்ததுன்னா அந்த function என்ன சொல்லலாம்னா uniformly continuous on r னு சொல்லலாம். uniformly continuous on r. And every function from rd ன்றது discrete metric அப்படின்னு சொல்லுவோம். every function from rd that is discrete metric reals with discrete metric into a metric space is uniformly continuous, in rd ல d of x comma y என்ன 1 for x is not equal to 0 க்கு, d of distance of x and y is 0 for x equal to y க்கு. So for the given epsilon greater than 0, choose del equal to 1 by 2, choose delta equal to 1 by 2. Then for x comma y belongs to rd, d of x comma y is always less than delta. So therefore d of x comma y equal to 0 for so x equal to y. So therefore d of f of x comma f of y is equal to 0, that is less than delta, is less than epsilon. Therefore f is uniformly continuous. So the function from rd to metric space, any other metric space, okay, that is called the uniformly continuous. Every function from rd to metric space is uniformly continuous. And m under the metric space, x naught under the any point on the metric space, and f of x equal to rho of x comma x naught, x naught define பண்ணிருப்பேன். x is belongs to m na, that is that function f is called uniformly continuous on m. f is called uniformly continuous on m. And a uniformly continuous function sends Cauchy sequence to Cauchy sequence. So that is the uniformly continuous function sends Cauchy sequence to Cauchy sequences. So the next topic is monotonic function. So let f be a real valued function defined on a set S, subset S of R. The f is said to be increasing or non-decreasing on S அப்படின்னா Already monotonic sequence பார்த்தோம். This is the monotonic function. So every pair of points x and y in S, that is x is less than y இருந்ததுன்னா f of x less than or equal to f of y. X less than that is f of x less than or equal to f of y na, that is called the function is said to be increasing. X less than y இருந்தது f of x strictly less than y இருந்தா f is said to be strictly increasing function. Decreasing, strictly decreasing function இதே மாதிரி define பண்ணலாம். That is இங்க x less than y இது மாறாது. இங்க f of x greater than f of y இருந்தா that is strictly decreasing அர்த்தம். இங்க x less than y இருந்து f of x greater than equal to f of y இருந்தா that is called the decreasing அர்த்தம். ஒரு ஃபங்க்ஷன் வந்து மோனோட்டோனிக் ஃபங்க்ஷன் சொல்லணும்னா the function வந்து ஒன்று இன்க்ரீசிங்காக இருக்கணும் இல்லை டிக்ரீசிங்காக இருக்கணும். either increasing or decreasing. இதனுடைய ப்ராப்பர்ட்டிஸ் பார்த்தீங்கன்னா that is f is increasing on a comma b அப்படின்னா f of c plus your particular c plus means right hand limit at the point c, left hand limit at the point c, that is called f of c minus. Both are exist for each c in a comma b, open interval a comma b, and the f of left hand limit and right hand limit இடையில the function value f of c minus less than or equal to f of c less than or equal to f of c plus. At the endpoints means a and b. At the endpoints f of a less than or equal to f of a plus and f of b minus less than or equal to f of b. Okay, f of b minus less than or equal to f of b. So this is one of the result, and fb is strictly increasing on s at s now. Strictly increasing function இருந்ததுன்னா function on S at S in R, f inverse exists and strictly increasing on f of S. F inverse exists and strictly increasing on f of S. And f is strictly increasing and continues. Strictly increasing and continues on a compact interval, that is closed and bound interval a comma b. Then என்ன சொல்லலாம்னா f inverse is continuous and strictly increasing on the interval f of a comma f of b ன்னு சொல்லலாம். f of a comma f of b ன்னு சொல்லலாம். These are some result based on the monotonic function. Actually monotonic function specific இல்லை உங்களுக்கு. So and fb defined on the open interval a comma b, and assume that for each interior point x in x of a comma b, there exists a ball b of x with the center x and the some radius in which f is increasing. F is an increasing function throughout a comma b. So f என்றது defined at the open interval, and for each interior point a comma b, open interval a comma b ல there exists some open ball. அந்த open ball ல the function is increasing இருந்ததுன்னா அந்த throughout the function a comma b ல the function is increasing அர்த்தம். Okay, that is the idea. And fb continues on the compact interval a comma b, and f doesn't have the local maximum. That is very important. Assume that f doesn't have the local maximum or local minimum at any interior point of the a comma b. Function is continuous on the compact interval a comma b. உள்ள இருக்கிற எந்த பாயிண்ட்லையும் இந்த ஃபங்க்ஷன் வந்து லோக்கல் மேக்ஸிமம் லோக்கல் மினிமமும் இல்லை, ஆனால் the function is continuous. ஓகே, அப்படின்னா என்ன அர்த்தம்னா the function must be monotonic on a comma b. Monotonic on a comma b means either increasing or decreasing. Okay. F is 1-to-1 and continues on the closed and bounded interval a comma b. F must be strictly monotonic on closed interval a comma b. Okay, the function 1-to-1 continuity இருந்தாலே போதும், that is called strictly monotonic on closed interval a comma b. That is every topological mapping of a comma b onto the interval c comma d must be strictly monotonic. This is the very important result in the based on the monotonic function fb increasing function defined on closed and bound interval a comma b x1 x2 xn என்றது n points எங்க அப்படினு பார்த்தீங்கன்னா interior of the interval a comma b so அதனால a less than x1 less than x2 and so on less than xn less than b actually பார்த்தீங்கன்னா this is a summation k equal to 1 to n f of xk plus minus f of xk minus less than or equal to f of b minus f of a plus okay so உள்ள இருக்கிற பாயிண்ட் இன்டீரியர் பாயிண்ட் எல்லாத்துலேயுமே அந்த ஈச் அண்ட் எவ்ரி பாயிண்ட்டுக்கு ரைட் ஹேண்ட் லிமிட் மைனஸ் லெஃப்ட் ஹேண்ட் லிமிட்னுடைய டிஃப்ரென்ஸ் உள்ளே இருக்கிற அத்தனை இன்டீரியர் பாயிண்ட்லேயும் தட் இஸ் n பாயிண்ட்ஸ் எடுத்திருக்கோம் ஓகே n பாயிண்ட்ஸுக்கும் ரைட் ஹேண்ட் லிமிட் மைனஸ் லெஃப்ட் ஹேண்ட் லிமிட் அதோட டிஃப்ரென்ஸினுடைய சம்மு என்னவாக இருக்கும் அப்படின்னு பார்த்தா லெஸ் than or equal to n பாயிண்ட்னுடைய ஓகேவா த லெஃப்ட் ஹேண்ட் லிமிட் பியினுடைய லெஃப்ட் ஹேண்ட் லிமிட் மைனஸ் ஏனுடைய ரைட் ஹேண்ட் லிமிட் ஏனுடைய ரைட் ஹேண்ட் லிமிட்னுடைய டிஃபரன்ஸுக்கு பவுண்டடாக இருக்கும் தட் இஸ் லெஸ் than or equal to f of b minus minus f of a plus that is a very important one and set of discontinuities that is we can deduce from the set of discontinuities of f is countable set of discontinuities of f discontinuities that is a jump னு அர்த்தம் இந்த xk plus xk minus னா there is some jump இருக்கு அப்படின்னு அர்த்தம் jump இருக்குன்னு jump discontinuity that is a set of discontinuities of f அந்த ஃபங்க்ஷன் உடைய f ன்றது ஒரு increasing function on the closed and bounded interval a comma b ல அப்படின்னா set of discontinuities of f ன்றது countable இருக்கும் அப்படின்னு அர்த்தம் that is very important result and f has a point of continuity in every open subinterval of a comma b f has a points of continuity in every open subinterval of a comma b and the given example of the function f defined and strictly increasing on a set s in R, strictly increasing on a set S in R, then f inverse is not continuous on f of s. Okay, the s ன்றது 0,1 union 2,3 னு எடுத்துக்கிறோம் ஒரு ஃபங்க்ஷன் டிஃபைன் பண்ணுறோம் x belongs to 0,1 x plus 1 x belongs to 2,3 இங்கே ஃபங்க்ஷன் பார்த்தீங்கன்னா strictly increasing on s இது வந்து strictly increasing on s the function f of s நீங்கள் கண்டுபிடிச்சிங்கன்னா that is f of s ன்றது 0,1 union 3,4 இல்லையா அதனுடைய inverse function define பண்ணிங்கன்னா how to define the inverse function the f of x ன்றது that is y equal to x and y equal to x plus 1 so the inverse function we can define for this x equal to y and x equal to y minus 1 so this is defined for 0,1 this is defined for what about that x equal to 2,3 this is the f of x that is a 3,4 okay இதெல்லாம் மாறாது that is a 0,1 தான் பட் இங்கே வரும்போது that is a 2 plus 1 that is equal to 3 and 3 plus 1 equal to 4 so the function f of x is belongs to 3,4 f of x belongs to 3,4 so 0,1 union 3,4 அப்படின்னா இது வந்து என்ன ஆகும் 0,34ல டிஃபைன் பண்ணுவோம் that is x equal to y minus 1 so that is the inverse function f inverse of y என்றது so consider the point actually நாம என்ன ப்ரூவ் பண்ணணும் the inverse is not continuous in the point any other point that is f inverse of something so இங்க பார்த்தீங்கன்னாவே ஜம்ப் இருக்கு that is 1 2 3 0 to 1 ஒரு function and 3 to 4 is the another function so consider the point y equal to 1.5 and which is not in f of s or better consider the behavior of the y equal to 1 for approaching 1 that f inverse of y approaches to 1 that is the gap in f of s between the 1 and 3 so we cannot approach from the above so therefore it doesn't show that the discontinuity at a point in f of s so that is the example okay functional பாருங்க, that is the discontinuity. And f is strictly increasing on a subset S of R, and assume that image f of s have the one of the following property. Image f of s has the one of the following. F is strictly increasing on a subset S of R na f of s as one of the following property. The first one, f of s open irukkalam, f of s is connected, and f of s is closed. Okay, in the f of s open, f of s connected, illa f of s closed irundaduna f must be continuous on s. F must be continuous on s. Okay. And b of s denote the set of all real valued function which are defined and bounded on a non-empty set S. Okay, set of all real valued function defined bounded on a non-empty set S. If f belongs to f b of s na norm of f into the supremum of mod f of x. The norm f is called the supremum of the norm, supremum norm of f. The norm f is called the supremum norm of f. Then the d of f comma g norm of f minus g is defines a metric d on b of s, and the metric space b of s comma d is complete. B of s comma d is complete. So the next topic is the derivative. Okay, continuity and uniformly continuity mostly important. Uniform continuity la or question கேட்பாங்க, mostly if it's condition and apply பண்ணீங்கன்னா you can check the uniformly continuity. And the function derivative means a function is defined on the open interval a comma b, the two distinct point x and c in the open interval a comma b, we can form the difference quotient, that is f of x minus f of c divided by x minus c. So c fixed, and the behavior of the quotient at x tends to c, that is the f is defined the open interval and c is belongs to the open interval a comma b, and f is said to be is differentiable at the point c na the limit of the quotient f of x minus f of c divided by x minus c at the point x equal to c, that is exist ஆகும். limit of the quotient at the point x equal to c is exist ஆச்சுன்னா the function is called the differentiable at the point c. So the function has the derivative of f at c, that is called denoted as f dash of c. F dash of c is exist ன்னு அர்த்தம். So f dash of c equal to limit x tends to c f of x minus f of c divided by x minus c is exist. So for example f of x equal to x square na, then any c belongs to R. F dash of c into the limit x tends to c, f of x into the x square, f of c into the c square divided by x minus c. When you apply the a square minus b square formula apply பண்ணீங்கன்னா we get the 2c. So already we know that this is the 2x, and 2x plus c போட்டிங்கன்னா there is a 2c. So the derivative of the function is 2c, and the derivative, what is the connection with the continuity? The function is defined on a comma b and differentiable at a point c in a comma b. differentiable at the any interior point C in the open interval a comma b. Then there is a function f star that is depending on f and on c, which is continuous at C, and which satisfy the equation f of x minus f of c equal to x minus c into f star of c. For all x in a comma b, f star of c equal to f dash of c. Therefore, there is a function f star that is continuous at a point c, which is satisfy the equation. Then f is differentiable at c, that is f dash of c equal to f star of c. Okay. Function is differentiable at c, no, that is implies the continuous at c. F is not continuous அப்படினா that is implies f is not differentiable. But continuous இருந்தா differentiability implies ஆகாது. அது எந்த கேஸா இருந்தாலும் சரி, differentiability இருக்குன்னா continuity implies ஆகும். Not continuousனா not differentiable அப்படின்னு சொல்லலாம். That is the algebra of the derivative. ரெண்டு function f and g ன்றது are differentiable at the point interior point of the a comma b அப்படின்னா அதனுடைய sum, difference, product is also differentiable at the same point on the interval, and the quotient if the condition g of c is not equal to 0, that is also differentiable at the point at the same point c. So that is called the product rule. So x square into sin x, the fg of dash of x. The chain rule என்னன்னு பார்த்தீங்கன்னா, that is called the f be defined on the open interval s, g ன்றது defined on f of s. G ன்றது என்னது? Defined on f of s. F ன்றது defined on s. Then composite function g of f is defined on s. G of f of x equal to g of f of x. G of f dash of c equal to g dash of f of c into f dash of c. That is called the chain rule. Okay. That means g of f is differentiable at c. In the case of f is differentiable at c, g is differentiable at f of c, and g of f is differentiable at c. One-sided derivative. Function is defined on the closed interval s, and assume that a function is continuous at the point c in s. F is said to have the right hand derivative at c அப்படின்னா the right hand limit extends to c plus f of x minus f of c divided by x minus c is exist இருக்கணும் and has a finite value. Or if the limit is plus infinity or minus infinity, the limit denoted as the limit is that is equal to limit is plus infinity or minus infinity. So the limit is denoted as f plus, that is the right hand derivative, f plus dash of c. Left hand derivative f minus dash of c, the same thing. C minus in the formula மாறாது, ஆனால் ஃபங்க்ஷன் வந்து ரைட் ஹேண்ட் லிமிட் லெஃப்ட் ஹேண்ட் லிமிட்டுக்கு டிஃப்ரெண்ட் ஃபங்க்ஷன் இருக்கும். அதை எடுத்து சப்ஸ்டிட் பண்ணி நம்ம ப்ரொசீட் பண்ணுற மாதிரி இருக்கும். சின்றது இன்டீரியர் பாயிண்ட் ஆஃப் எஸ் அப்படின்னா f has a derivative f dash of c that is equal to plus infinity. Interior point of s இருந்ததுன்னா f has a derivative that is equal to plus infinity if both right hand and left hand derivative at the point c that is called or plus infinity இருந்ததுன்னா the derivative is plus infinity. ரெண்டுமே வந்து that is called the plus infinity இருக்கும். The function வந்து பார்த்தீங்கன்னா cube root of x. So derivative at the point 0 பார்த்தீங்கன்னா that is equal to plus infinity. Because of பார்த்தீங்கன்னா limit extends 0, the f of x minus f of 0 divided by x minus 0, இது find out பண்ணீங்கன்னா that is called x power minus 2 by 3 ன்னு வரும். That is nothing but 1 by x power 2 by 3. As I extend 0, this has become the plus infinity. And f be a real valued function, that is means the derivative, that is the limit of the quotient is doesn't exist now. The derivative of the function does not exist at the point 0 ன்னு அர்த்தம். f ன்றது real valued function defined on a subset S of a metric space M, and a என்றது ஒரு some point in S, then f is said to have the local maximum at a. F is said to have a local maximum at A if there is a ball B of A such that f of x less than or equal to f of A. For all x in B of A intersection yes, B of A intersection yes, f of x greater than or equal to f of A for all x in B of A intersection yes, f is said to have the local minimum at A. This is the local maximum for that f of x less than or equal to f of A for every point of the open ball B of A intersection with S. F of x greater than or equal to f of A varundhana, that is called the said to be local minimum at the point A. Then f is defined on the open interval a comma b, f is the local maximum or local minimum at the interior point of the a comma b, then f has derivative at c, that f dash of c must be 0. That is very important point. இது நம்ம யூஸ் பண்ணி நிறைய ப்ராப்ளம் போட்டிருப்போம். So that is the local minimum, local maximum ஏதாவது interior point of the interval define ஆச்சுன்னா, that is the f dash, the derivative at the point is must be 0 அர்த்தம். Derivative at the point must be 0. And f of x equal to x square, that is the example. At the point this is a local maximum, sorry, local minimum at x equal to 0. Therefore f dash of 0 equal to 0. That is f of x equal to mod x as a local minimum at the point x equal to 0. This is a local minimum, and f dash of 0 doesn't exist. F dash of 0 doesn't exist. The left and right derivative differ. That is the idea. So that means f be defined at the open interval a comma b. Assume that for some c in open interval a comma b, f dash of c into the greater than 0 or f dash of c equal to plus infinity. Okay, then there is a ball b of c which is the subset of a comma b, in which f of x greater than f of c if x greater than c, f of x less than f of c if x less than c, then that is called so by the Rolle's theorem the function has the derivative, and at each point of the open interval a comma b, function derivative இருக்கணும், that is continuity, the function is derivative, differentiable and the open interval a comma b, and function is continuous on the closed interval including the end point, that is function is continuous on the closed interval a comma b. F of a equal to f of b, now there is at least one interior point at which f dash of c equal to 0, at which f dash of c equal to 0. That is called the Rolle's theorem. For this example, f of x equal to x cube minus x, define the minus 1 comma 1. இங்கே f of minus 1 f of 1 same இருக்கு. So and the function is continuous and differentiable in the open interval minus 1 comma 1, and the function is continuous because of it's a polynomial function. So we can apply the Rolle's theorem. There exists some point c belongs to minus 1 comma 1. Have derivative f dash of x பார்த்தீங்கன்னா 3x square minus 1 ன்னு வரும். So that is f dash of c equal to 0 னா 3x c square minus 1 equal to 0. So that is c equal to plus or minus 1 by root 3. So both points are minus 1 comma 1. Both points are in minus 1 comma 1. Okay. So அதனால c equal to plus or minus 1 by root 3. So the same way mean value theorem, assume that f has the derivative, once again the same assumption, hypothesis, f has a derivative at each point of the open interval a comma b, function is continuous in closed interval a comma b. இங்கே எப்படி கொடுத்திருப்பாங்கன்னா the statementல at both end points a and b ன்னு கொடுத்திருப்பாங்க. So there is some point c in a comma b, the f dash of c equal to f of b minus f of a divided by b minus a. So actually நம்ம இப்படி படிச்சிருப்போம், f of b minus f of a divided by b minus a. இதனுடைய generalization, generalized mean value theoremன்றது ரெண்டு ஃபங்க்ஷன் நம்ம எடுத்துக்கலாம், two functions. each having the derivative and the open interval a comma b, and each continues in the including at the endpoints a and b. Okay, derivative இருக்குனா continuity implies ஆகும், அதனால தான் அந்த ஸ்டேட்மெண்ட் இது மாதிரி கொடுத்திருப்பாங்க. And assume also that there is a no interior point x at which f dash of x and g dash of x are infinite. So infinity வர மாதிரி எந்த interior point இருக்காது. For some interior point c, so f dash of c divided by g dash of c, f dash of c into g of b minus g of a, g dash of c into f of b minus f of a. So that means sometime f dash of c divided by g dash of c equal to f of b minus f of a divided by g of e minus g of a. This is called the generalized mean value theorem. Okay. And the hypothesis is very important, and f of x, g of x under the two function edukurona. So we can, there exists some point f dash of c and g dash of c. So the g of pi by 2 minus g of 0 and f of pi by 2 minus f of 0. So cos c into 0 minus 1, that is equal to cos c equal to sin c. Tan c equal to 1, and the c should be pi by 4. So the pi by 4 is belongs to 0 comma pi by 2. Okay. This is called the extended mean value theorem. That is rendu function, once again. Rendu function, both are derivative finite or infinite at the each point of the open interval a comma b, and at the each end point, at the end points, the function f of a plus g of a plus f of b minus g of b minus exist and finite values. And assume further that there is no interior point x at which f dash of x and g dash of x are infinite. Then for some interior point c, that is f dash of c into g of b minus g of a equal g of b minus g of a plus g dash of c into f of b minus f of a equal f of b minus f of a plus. This is called the extended mean value theorem. And monotonicity and derivative, the function has the derivative at each point of the open interval a comma b. The f is continuous at the endpoints of a comma b. F dash take only the positive values. The derivative takes only the positive values in open interval a comma b. Then f is strictly increasing in a comma b. That is means f dash of x greater than 0 varanda, that is called the strictly increasing artham. Adha adukku artham. F dash negative values, okay, on in the interval a comma b means f dash of x less than 0. That means f is strictly decreasing on a comma b. That is f is constant on a comma b, na the f dash of c equal to 0. F dash of c, sorry, f dash of x equal to 0 for all x in a comma b, then function is constant on a comma b. This is the intermediate value property for the derivative. The function is defined on a closed and bounded interval, that is a comma b, that is called the compact interval. And f has derivative finite or infinite at each interior point. Assume also that f has a finite one-sided derivative, f plus dash of a illa f minus dash of b. That means b nuடைய left hand limit, a nuடைய right hand limit. Okay, at the end points, that is both are not equal, with both are not equal, then c is a real number between f of a plus, that is f dash of a plus இல்லையா, and f dash of b minus. Okay, இது ரெண்டுத்துக்கும் இடையில if c is a real number between f dash of a plus f dash of b minus, there exists at least one interior point x such that f dash of x equal to c. F dash of x equal to c. That is called the intermediate value property for the derivative. That is very important. So f has the derivative finite or infinite on a comma b and is continuous at the endpoints of a comma b. F dash of x is not equal to 0. In the case of f dash of x is not equal to 0 for every x in the a comma b, na f is strictly monotonic in artham. F is strictly monotonic on the a comma b in artham. And f dash is exist and is monotonic on the open interval a comma b, na the derivative is continuous in artham. The derivative is continuous on a comma b. Taylor's theorem, actually the nth derivative, that is the function is function finite, having finite nth derivative f power n everywhere in the open interval a comma b, and f power n minus 1 is continuous on the closed interval a comma b. The C is belongs to closed interval a comma b for every x in a comma b. X is not equal to C. There exists a point x1 interior to the interval joining x and c such that f of x equal to f of c plus summation k equal to 1 minus 1 f kth derivative idukku artham f cover kth derivative of the c divided by k by 2 x minus c whole power k at the point x1, that is x minus c whole power n. Okay, this is called the generalized Taylor's theorem. Actually Taylor's theorem is specific f and g into the two functions having the nth derivative, that is the f power n and g power n, and in the open interval a comma b, and continues the n minus 1th derivative and closed interval a comma b, and c is any point in the closed interval a comma b. Then for every x in the closed interval a comma b, which is x is not equal to c, there exists some point x1 interior to the interval joining the x and c such that this is equivalent to this one. Okay, this is f of x equal to e power x. We can find out the Taylor series for this one. E power x no expansion the actual Taylor series. When you try to find out the formula, that is f dash of x, f of x, f of 0 and f dash of x at the point 0 undradhanala, so f dash of 0 like that. Taylor series at the point 0 is called the Maclaurin series. F is a function f is said to be satisfy the Lipit's condition of order alpha at c if there exists a positive number m, there is a positive number m which may be dependent on c, and a ball b of c, such that f of x minus f of c less than m into x minus c whole power alpha. This is Lipit's condition of order alpha என்றது இங்க whole power alpha ன்னு வரும். That is Lipit's condition of order alpha. Whenever x is belongs to b of c, c center உள்ள ஒரு open ball, x is not equal to c. Actually நமக்கு என்ன ஐடியா அப்படிங்கிறது, the function which satisfies the Lipit's condition of order alpha is continuous at c, is continuous at the point c if alpha is greater than 0, alpha positive இருந்ததுனா, and as a derivative at c, alpha is greater than 1 இருந்தா, alpha greater than 1 இருந்தா, the function has the derivative at c, alpha என்றது greater than 0 இருந்தா, the function is continuous at c. Okay, from the so from the Lipit's condition, how to define the continuity and derivative. And a given example of the function satisfying the Lipit's condition of order 1 at c for which f dash of c doesn't exist. And alpha greater than 1 இருந்தாதான் that is the derivative. So அதுக்கு ஒரு example. The first one கொஞ்சம் ஞாபகம், that is the result. For the second one, that is the example, that is called the f of x equal to mod x is the example. So that is the c equal to 0. At the point c equal to 0, the function is continuous, but at the point c equal to 0, the function is doesn't have the derivative. F dash of x does not exist. So இதில் Lipit's condition நீங்கள் apply பண்ணீங்கன்னா mod f of x, f of y, this is equal to mod x minus mod y. Okay, this is to satisfy that mod of x minus y. So this is the order 1. It is the order 1. So the function is continuous. Okay, what about the derivative? Derivative at the point 0. At the point 0, f dash of 0 does not exist. We know that about the function. F dash of 0 does not exist. The f of x equal to x minus x, x less than 0, plus x, x greater than equal to 0. So the f dash of x என்றது definition use பண்ணி prove பண்ணலாம். இல்ல கொஞ்சம் முட்டாள்தனமா பண்ணோம்னா that is minus 1 x less than 0 and plus 1 x greater than equal to 0. So that இங்க பார்த்தீங்கன்னா left hand limit right hand limit ரெண்டும் டிஃப்ரெண்ட்டாக இருக்குது. So the derivative doesn't exist at the point 0. At the point 0 derivative doesn't exist. Okay, 0 minus and 0 plus ரெண்டும் டிஃப்ரெண்ட்டாக இருக்கிறதுனால so f dash of 0 doesn't exist because the left hand right hand derivative different. So therefore Lipit's condition of order 1 என்றது continuity இருக்கு and derivative இல்லை. That is the example. So in the following, each of the following cases, determine the intervals in which the function f is increasing or decreasing and maxima and minima. Okay. So these are some examples. Actually increasing, decreasing, the derivative positive or that is called the increasing. F dash of x என்றது இங்க 3x square plus a ன்னு வருது. It's totally depend on the a. வெறும் 3x square வந்தனா that is always positive ன்னு சொல்லலாம். So a greater than 0 வருதா f dash of x greater than 0. அப்படினா f is strictly increasing on R அப்படின்னு சொல்லலாம். f is strictly increasing on R னா no local extreme on அர்த்தம். a equal to 0 ன்னு போட்டீங்கன்னா greater than equal to 0 ன்னு வந்துரும். அப்படினா f is increasing on R. அப்ப no strictly local minimum or maximum. a less than 0 எடுத்தீங்கன்னா that is called that 3x square minus a ன்னு வரும். f dash of x. ஓகே, இதை வச்சுட்டு இன்க்ரீசிங் டிக்ரீசிங்லாம் நம்மளால் சொல்ல முடியாது. ஸோ என்ன பண்ண முடியும், இதில் இருந்து பாயிண்ட்டை கண்டுபிடிக்க முடியும். பாயிண்ட்டை கண்டுபிடிச்சா என்ன வரும், தட் இஸ் ஏன்றது ஒரு நெகட்டிவ் வேல்யூ. ஸோ எக்ஸ் ஈக்குவல் டு ப்ளஸ் ஆர் மைனஸ் ரூட் ஆஃப் மைனஸ் ஏ பை 3. ஸோ தட் இஸ் இங்கே ப்ளஸ் ஏன்னு இருக்கிறதுனால ஏன்றது நெகட்டிவ் வேல்யூ. ஸோ இங்கே ப்ளஸ் வந்துடும் ரூட்டுக்குள்ளே. ஸோ எக்ஸ் லெஸ் தென் சம்திங் எடுத்திங்கன்னா ஓகேவா. ஸோ திஸ் இஸ் அ ரியல் லைன். This is minus root of minus a by 3. I thought this is the plus root of minus a by 3. So this is the minus infinity to plus infinity. In the interval the function is another f dash of x that is greater than 0 and greater than 0 that is called 3x square something. Okay. So this is a x greater than minus a by root 3, minus a by root 3. In the interval the function is f dash of x is greater than 0. And lies between the minus a by root of minus a by root 3 to plus root of minus a by root 3 la, the f dash of x is less than 0, that is decreasing. So that is either inga vandu increasing, either decreasing, either increasing. Okay. So the increasing to decreasing na enna varuna, the corresponding point la, this is the increasing to decreasing, the function is attains the local maximum. So local maximum at the point this one, ஏன்னா இது increasing to decreasing என்றதுனால. இது decreasing to increasing. So decreasing ல இருந்து இந்த interval ல decreasing, so decreasing to increasing na, that is the local minimum attain ஆகும். So local minimum at the point root of minus a by root 3. So this is some real number. Okay, ரூட்டுக்குள்ள மைனஸ் வருதுன்னு திங்க் பண்ணக்கூடாது. தட் இஸ் ஏன்றது நெகட்டிவாக எடுத்திருக்கோம், அதனால் root of positive. The same way you can check the what about the f of x equal to log of x square minus 9. That is log of x square minus 9 என்றது domain வந்து mod x greater than 3. Domain வந்து mod x greater than 3. That means minus infinity to minus 3 and 3 comma infinity. That is the domain. So f dash of x என்றது 2x by x square minus 9. So f dash of x என்றது x greater than 3 na, what is that denominator in agum? X greater than 3 na, the denominator on the 2x by x square minus 9, that is x minus 3 into x plus 3 into x minus 3. So x is greater than 3, x is less than minus 3, x is less than minus 3 now, this is negative, this is negative, negative multiple of positive, so this is denominator positive, numerator negative, so the f dash of x is less than 0. X greater than 3 na, this is positive, idum positive, denominator positive, numerator positive, and f dash of x greater than 0. That is increasing, either decreasing. Okay. So x greater than 3 now increasing, x less than minus 3 now decreasing. So increasing to less than minus 3. So no local maxima or minima in the open domain, because our naduli or break vanduruchu, that is called that minus 3 and plus 3. இந்த இடத்துல ஃபங்க்ஷனே டிஃபைன் பண்ணல, no function. So no local maxima or minima in the open domain, derivative never 0, domain is open intervals. Okay. Saying f of x equal to something, f dash of x கண்டுபிடிச்சிங்கன்னா the critical point like this, f dash of x 0 க்கு equal பண்ணா critical point. இதிலிருந்து you can check it, which is the 0 to 1 by 7 ல அந்த f dash of x நோட நேச்சரை வச்சுட்டு that is positive negative ஆன்றதை guess பண்ணலாம். That is defined the 0, 1 by 7, here 1. So 0 to 1 by 7 la the function is increasing, and 1 by 7 to 1 la the function is decreasing. So inge that is called increasing to decreasing என்றதனால the function has local maximum at the point 1 by 7. At the point 1 by 7 the local maximum arise ஆகும். So the same way for the sin x by x. Sin x by x, x is not equal to 0, and this is equal to 1 for x equal to 0. இங்கே breaking point கொடுத்துருக்காங்க, ஆல்ரெடி பார்த்த எக்ஸாம்பிள் தான். And 1 for x equal to 0. ஸோ இங்கே டெரிவேட்டிவ் கண்டுபிடிச்சிங்கன்னா லைக் தட் இது மாதிரி கிடைக்கும். g of x equal to the something மேலே இருக்கிறத எடுத்துக்கிறோம். ஸோ g dash of x கண்டுபிடிச்சிங்கன்னா that is less than or equal to 0 for every x belongs to 0 to 5 by 2. இங்கே கொடுத்துருக்க இன்டர்வல் 0 to 5 by 2 தான். And g is decreasing. ஏன்னா கீழே இருக்கிறது ஆல்வேஸ் பாசிட்டிவ். ஓகேவா, தட் இஸ் ஆல்வேஸ் பாசிட்டிவ். ஸோ இந்த மேலே இருக்கிறதுனுடைய நேச்சர் வந்து g is decreasing சொல்லலாம். ஃபார் தட் g dash of x வந்து less than or equal to 0ன்றதுனால. So therefore g of 0 equal to 0, and that is g of x less than or equal to 0. So f dash of x less than or equal to 0 for x greater than 0. Okay. So therefore f is decreasing on 0, 5 by 2. So the maximum at x equal to 0, f of 0 equal to 1, and the minimum at x equal to 5 by 2, that is called the 2 by pi, f of 5 by 2 equal to. This is the polynomial. Find the polynomial f of lowest possible degree. Lowest possible degree such that f of x1 equal to a1, f of x2 equal to a2, f dash of x1 equal to b1, f dash of x2 equal to b2. x1 not equal to x2, a1, a2, b1, b2 are the given real numbers. So that is the lowest degree polynomial. That means 4 conditions. That is f of x1 equal to a1, f of x2 equal to a2, f dash of x1 equal to b1, f dash of x2 equal to b2. So try for the cubic polynomial. The derivative கண்டுபிடிச்சிட்டு that is equal to a1, a2, b1, b2, so like that. With the condition x1 is not equal to x2. So there is a cubic polynomial. The explicit cubic can be constructed, that is for the lowest degree, which is 3. And f of x equal to e power minus 1 by x square, and define the function f of x equal to e power minus 1 by x square, that is x is not equal to 0, and 0 for x equal to 0, x equal to 0 to 0. Thus show that f is continuous for all x, the function is continuous for all x. The nth derivative is also continuous for all x, but nth derivative at the point 0 equal to 0 for n equal to 1, 2, 3 and so on. The function that is the 1 by x square at x is approaches to 0, 1 by x square approaches to infinity. So e power minus 1 by x square, the e power minus infinity value 0. That is approaches to 0. So e power minus infinity is equal to 0 and e power minus 1 by x square approaches to 0 as x tends to 0. So this is 0 equal to f of 0. So from this, what is the conclusion? Function is continuous at x equal to 0. That is limit x tends to 0, f of x equal to 0, that is equal to f of 0. So therefore function is continuous at x equal to 0. And second one nth derivative. இதனுடைய nth derivative பார்த்தீங்கன்னா, that is the nth derivative of x, polynomial in 1 by x, polynomial in 1 by x, and e power minus 1 by x square. ஏன்னா e power something differentiate பண்ணா e power something தான், and power differentiate பண்ணி productல போடுவோம். And the nth derivative at the point 0 is obviously 0 because of f of 0 equal to 0 ன்றதுனால. So n equal to 1 ன்னு எடுத்தீங்கன்னா, that is called the f dash of x ன்றது 1 by x square differentiate பண்ணா minus 2 by x cube, 1 by x square. So e power something minus 1 by x square into minus 2 by x cube, that is called the f dash of x. Am I correct? So that is equal to 2 by x cube e power minus 1 by x square. Already there is a minus, so this is become the place. So 2 by x cube into e power minus 1 by x square for the first derivative. That is the p1 of t equal to here 2t cube, 2t cube nu vechikalam. That is p1 of t equal to, yana p1 of 1 by x la function, 1 by x equal to t nu vechikanga, that is p1 of t equal to 2t cube. That is a p1 function. இதுக்கு limit x tends 0 நீங்க கண்டுபிடிச்சீங்கன்னா, that is the derivative at the point 0 is existent சொல்லணும். Derivative at the point 0 கண்டுபிடிச்சீங்கன்னா x tends to 0, that is equal to 1 by x into 1 by x, limit x tends 0, e power minus 1 by x கீழே கொண்டு வந்துட்டீங்கன்னா 1 by x by something, so t equal to 1 by x na t by et square, that is 0, t tends to 0 this is the answer. So as t equal to 1 by x na limit t tends to infinity, இல்லை டைரெக்டாக போட்டிங்கன்னா that is infinity by infinity வரும். I thought டைரெக்டாக இங்கே கூட லிமிட் போட்டிருக்கலாம். So that is the infinity by infinity. So t equal to 1 by x na t tends to infinity போட்டிங்கன்னா e power infinity infinity, anything by infinity is 0. So the t is approaches to plus infinity minus infinity, the function value is 0, that means limit x tends 0 equal to 0. So f dash of 0 equal to 0, f dash of 0 equal to 0, so limit x tends 0, f dash of x equal to exist and is equivalent to 0 now. And f dash is continuous. From this, what is the conclusion? The derivative is continuous, derivative is continuous. So we can find out for the nth derivative, that is the n plus 1th derivative. Skip it. The same way, these are other examples, f, g, h, f of 0, g of 0, h of 0, இது எல்லாமே 0. The function is f of x, for x is not equal to 0 க்கு sin of 1 by x, இது x into sin of 1 by x, இது x square into sin of 1 by x. இதனுடைய டெரிவேட்டிவ் எக்ஸிஸ்டா அப்படின்றத கேட்குறாங்க. that is the called f dash of 0 doesn't exist and g dash of 0 doesn't exist, but h dash of 0 equal to 0, h dash of 0 equal to 0. Okay, the derivative at the point 0 வந்து 0 னு அர்த்தம். g dash of 0 doesn't exist. Okay, so இது மாதிரி டெரிவேட்டிவ் கண்டுபிடிச்சு போடும்போது இது லிமிட் அப்ளை பண்ணி தான் ஃபங்க்ஷன் அப்ளை பண்ணி ப்ரொசீட் பண்ணலாம். So that is called the limit x tends 0 f of x minus f of 0 divided by x minus 0. So sin of 1 by x divided by x. As x tends 0 பார்த்தீங்கன்னா sin of 1 by x ன்றது oscillate ஆகும். 1 by x ன்றது infinity ஆகும். அப்படின்னா no limit is exist. So f dash of 0 does not exist. f dash of 0 does not exist. இதே மாதிரி தான் for this one. But பிரச்சனை hக்கு என்ன வரும்னா உங்களுக்கு வந்து x into sin of 1 by x வந்துடும். நீங்கள் sin of 1 by x oscillate ஆனாலும் this is approaches to 0. So 0 into anything is 0 ஆகிடும். அதனால தான் h dash of 0 equal to 0 னு வருது. இந்த டெரிவேட்டிவ் வேணால் சாதாரணமாக டிஃப்ரென்ஷியேட் பண்ணணும். அண்ட் f1, f2, g1, g2ன்றது 4 functions. Okay, having the derivative in a comma b. Having the derivative in close open interval a comma b. Define capital F by means of the determinant, that is f1, f2, the first row, second row வந்து g1 of x, g2 of x. So what is the derivative of f dash of x? இது recent timeல இங்கே பார்த்தோம் ஒரு competitive examல. So that is the capital f dash of x equal to f1 dash f2 dash இங்கே g1 g2 plus f1 f2 divided by g1 dash g2 dash. The derivative of the determinant of the function we can define like that. Okay, that is a very important. Very simple result. So that is the given a function. The formula in the mean value theorem can be written as the f of x plus h minus f of x divided by h, like that. இது மாதிரி எழுதலாம் derivative னுடைய formula. That is theta is sliced between the 0 to 1. Theta is a function of x and h. When f of x equal to x square, f of x equal to x cube, f of x equal to e power x, f of x equal to log x. So find the limit h tends 0. h tends 0 னா என்ன ஆகும்? This is become the actually structure இதுதான். Actually நாம் படிச்சிருப்போம் ஸ்கூல் லெவல்லையே. Actually structure இது limit h tends 0 f of x plus h minus f of x divided by h. This is exist and a derivative is exist, that is equivalent to f dash of x. Okay. So இங்கே h tends 0 னா this has become the f dash of x. Actually structure main structure இதுதான். The theta is lies between the 0 and 1. 0 க்கு 1 க்கு இடையில thetaன்றது இருக்கும். For example இங்கே பாருங்க, that is the mean value theorem on x and x plus h, f of x plus h minus f of x, h into f dash of x plus theta h. Theta is lies between 0 to 1. So இங்கே நாம் என்ன பண்ணணும்? f of x equal to x square கண்டுபிடிக்கணும். அப்படி f dash of x என்ன 2x. So that is equation பார்த்தீங்கன்னா இதில் limit h tends 0 x plus h whole square minus x square divided by h 2 into x plus theta h. ஸோ இதை எக்ஸ்பேண்ட் பண்ணி சிம்பிளி பண்ணிங்கன்னா உங்களுக்கு கிடைக்கிறது 2x plus hன்னு வரும். h காமனாக வெளியே எடுத்து கேன்சல் பண்ணினா 2x plus h equal to இங்கே 2 into x plus theta hன்னு வருது இல்லையா? f dash of x equal to 2xன்றதுனால f dash of x plus theta h 2 into x plus theta hன்னு வருது. ஸோ 2x plus 2 theta hன்னு வரும். So this is equal to h equal to 2 theta h. So from this h cancel ஆச்சுன்னா theta equal to 1 by 2. 1 by 2 is always lies between the 0 to 1. So limit theta h tends 0 theta என்றது limit h tends 0 that is equal to theta என்றது that is equal to 1 by 2 என்றதுனால. So நீங்கள் டைரெக்டாக ப்ரொசீட் பண்ணலாம். limit h tends 0 that is called f of x plus h minus f of x divided by h. So that is limit, that is called the f dash of x. h tends 0 ன்னு போட்டிங்கன்னா இங்கே f dash of x ஆகிடும். தீட்டான்றதை we can find out, that is the idea. So limit h tends 0 f of x plus h என்றது x plus h whole cube minus f of x என்றது that is called the x cube divided by h. இதில் சிம்பிளி பண்ணிங்கன்னா x cube cancel ஆகிடும். So that is limit h tends 0 that is called 3x square ன்னு ஆன்சர் வரும் இல்லையா. ஸோ இதை டிஃப்ரென்ஷியேட் பண்ணிங்கன்னா x cube டிஃப்ரென்ஷியேட் பண்ணிங்கன்னா இதில் அந்த theta value we can find out the theta value. Theta value is 1 by 2. Okay. அந்த ஃபார்முலா அப்ளை பண்ணி we can find out the theta value. e power x பார்த்தீங்கன்னா e power xக்கு ஸோ theta h equal to like this இது மாதிரி வருது. e power theta h equal to e power something வருது. ஸோ theta h equal to taking log on both side. e power நான் எலிமினேட் பண்ணணும்னா log எடுக்கணும். ஸோ theta equal to 1 by h log of e power h minus 1 வருது. இதில் as h tends 0 நீங்கள் போடும்பொழுது we get the theta. Theta is approaches to 1 by h log of 1 plus 0 of h. So 1 by h O of h என்றது approaches to 0. So therefore this is equal to approaches to theta is approaches to 1 by h by 2. So 1 by once again we get this is equal to approaches to 1 by 2. Okay. And log x பார்த்தீங்கன்னா இதே மாதிரி f dash of x அந்த thetaன்றது 1 by 2. So that is the conclusion for a, b, c, d limit h tends 0 theta is always 1 by 2. And f of x equal to 3x power 4 plus minus 2x cube minus x square plus 1. g of x equal to 4x cube minus 3x square minus 2x. So the f dash of x by g dash of x is never equal to the quotient f of 1 minus f of 0 divided by g of 1 minus g of 0 if x is sliced between 0 to 1. X is sliced between 0 to 1. So there is no x is belongs to 0 comma 1. The f dash of x by g dash of x equal to 0. So that means what is the என்ன பண்ணணும்னா g dash of x never 0 in 0 a comma b ன்னு சொல்லணும். அப்படி சொன்னாதான் we get the conclusion. Okay. So leave it. Given a function f defined and having the finite derivative f dash the of open interval 0 to 1 such that modulus of f dash of x less than 1. Modulus of f dash of x less than 1, define a n equal to f of 1 by n for n equal to 1 to 3 and so on. Then limit n tends infinity a n is exist. Limit n tends infinity a n is exist. The same way f has the finite derivative at each point of the open interval a comma b, and the limit x tends to c f dash of s exists is finite for some interior point c, then value of this limit must be f dash of c. Value of this limit is f dash of c. So f has the derivative, f has a finite derivative in the open interval a comma b and is continuous in the closed interval a comma b with the condition f of a, f of b equal to 0. So for every real lambda there is some c in the open interval a comma b such that f dash of c equal to lambda into f of c. Okay, well, that is Rolle's theorem. Okay, generally f dash of c equal to 0 nu poduvom. So here f dash of c equal to lambda f of c, that is for every real lambda there exists some point in the open interval. Okay, but then such that f dash of c equal to lambda into f of c naduvalla. That is assume that f is continuous on a comma b. F is continuous on closed interval a comma b. Find its second derivative f double dash open interval a comma b and the line segment joining a comma f of a, b comma f of b intersect the graph of f in a third point p different from a and b. Then the second derivative must be 0. Second derivative must be 0 at the point. Like think panningana you can understood what is the idea and f has the finite third derivative. F has the finite third derivative f triple dash in closed interval a comma b. F of a, f dash of a, f of b, f dash of b equal to 0. Then the second derivative at the point c equal to 0 for some c in a comma b. Okay. F be a non-negative and has a finite third derivative f triple dash in the open interval. If f of x equal to 0 for at least two values x in 0 comma 1, and then the second derivative must be equal to 0 at the point. This is உங்களுக்கு தெரிஞ்ச விஷயம் f has the finite derivative and c is any point a comma b. For every epsilon greater than 0 there exists here one ball b of c comma delta. The radius delta depends on the epsilon, not on c. Therefore x belongs to the open ball. The center c some delta x is not equal to c. The derivative definition of the okay, well, the limit extends c f of x minus f of c divided by x minus c is equal to f dash of c. So the difference of the f of x minus f of c, the quotient and f dash of c is always less than epsilon. This is the definition of the derivative. That is the condition from the uniform continuity. And f has the finite derivative in a comma b and is continuous in the closed interval a comma b. F of x is always lies between the a and b for all x in a comma b. X in a comma b, the f dash of x is less than or equal to alpha. Alpha is less than 1 for all x in a comma b. Then f has a unique fixed point in the closed and the bounded interval a comma b. Under this condition, this is a given example. The pair of function having the finite derivative in the open interval 0 comma 1 such that limit extends 0 f of x by g of x equal to 0, like that example. That is f of x equal to x square, g of x equal to x square sine of 1 by x. Remember, f and g have two function having the finite nth derivative in a comma b. For some interior point c in a comma b, assume that f of c and f dash of c n minus 1th derivative at the point c equal to 0, g of c equal to g dash of c equal to g power n minus 1th derivative at the point c equal to 0, and g power n x is never 0 in the open interval a comma b. Then the limit extends to c f of x by g of x equal to like this. Taylor's theorem.